Here we have a problem on derivative. That is, we have a function y equals to natural logarithm of, again, natural logarithm of x, and we have to find dy over dx using chain rule. That is, we have to find the derivative of this function with respect to x. Okay, so in the given function on the right side, so here instead of x, if I just have x, what will happen? Then we'll have ln x. And I can get the derivative of this ln x easily. So whenever we have natural logarithm of x, its derivative is just 1 over x. So at the place of ln x over here, that is the argument of this logarithm must be single variable, so that I can get derivative of this one easily. So since I need single variable at the place of this ln x, we can assign a new variable for this ln x. That is, let t is equal to ln x. Okay, then the given function will become what? Y equals to ln of. So for this ln x, we have assumed t. So we get ln t. And also already we know that already we have taken t is equal to ln x. Okay, according to the question, we have to find dy over dx. That is derivative of y with respect to x. Okay, in this function we have y. Is it possible to find derivative of y with respect to x? No, it's not possible, because here y is a function of t. Since y is a function of t, we can find derivative of y in this function with respect to t. Further, t is a function of x. So we can find derivative of this t with respect to x, then we get dt over dx. So this is called chain rule. Okay, now what we need to do is we have to plug in this ln t for this y over here and ln x for t over here. Let me do it in the next step. So dy over dx equals to d of, for this y, we can plug in ln t over dt times, for this t we can plug in ln x, so d of ln x over dx. Okay, so dy over dx equals to, okay, here when I find derivative of this ln t with respect to t, so I'm getting 1 over t. And when I find derivative of this ln x with respect to x, I'm getting 1 over x. So dy over dx equals to 1 over, when I multiply 1 times 1 is 1, I get 1 in numerator. When I multiply t and x, I'm getting tx, or it can also be written as x times t. Okay, so dy over dx equals to, okay, actually t is a variable taken by us. We should never give the final answer in terms of the variable which was taken by us. So it has to be replaced by the original stuff. What do we know for t? So we know that t is equal to ln x. So this t has to be replaced by ln x. So I'm getting 1 over x times ln x. So now I got the derivative of the given function. So the derivative of the given function equals to 1 over x times ln x.